Engineering Conversation and Innovation. This is Schulich Connects, proudly sponsored by TD Insurance.
The privilege of serving as the interim dean of the Schulich School of Engineering. And it's wonderful to see you all here this morning to join us for this morning's Schulich Connects event entitled Balancing Tradition and Innovation in Energy. And this event is proudly sponsored by TD Insurance. Before we get started here this morning, I'd like to take a moment to acknowledge that we are gathered here this morning on the traditional territories of the peoples of Treaty 7 here in southern Alberta. And this includes the Blackfoot Confederacy, comprising the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda, including the Chiniki, Bears Paw, and Goodstoney First Nations. And the City of Calgary is also home to Métis Nation of Alberta Districts 5 and 6. So as the energy landscape undergoes rapid transformation, engineers are really at the forefront of balancing traditional practices in oil and gas with the demands of sustainability and innovation. And this event will explore the future of energy, bridging the gap between conventional methods and innovative solutions that address climate change, regulatory shifts, and the need for cleaner and more efficient energy systems. Our panel will discuss how energy engineering is driving the sector's evolution with a focus on responsible development, cutting-edge technologies, and the integration of renewable energy. Before I pass it over to our speakers, just quickly some logistics. There will be an opportunity to ask questions later on in the program, so please hold your questions until then, and we will have somebody with a microphone come to you and give you an opportunity to ask your questions of the panel. I'd now like to introduce you to Dr. Josephine Hill, today's moderator. Dr. Hill is a professor in the Department of Chemical and Petroleum Engineering here at the Schulich School of Engineering. She is currently the president of the Canadian Catalysis Foundation, the chair of the Chemical Institute of Canada, and an editor of the journal Applied Catalysis. Dr. Hill is also a fellow of the Engineering Institute of Canada, the Chemical Institute of Canada, and the Canadian Academy of Engineering and Engineers Canada. Her research and mentoring excellence have been recognized with many awards. So I'd like to pass it over now to Josephine, who will introduce us to today's panel. Josephine, over to you.
Thank you, Anders. So lovely to see everybody this morning on this somewhat chilly day. I walked my dog at 6 a.m. and the hoarfrost looked lovely, but it was cold. So thank you for coming. So you've already heard a little bit about my background. I work in catalysis and valorizing waste materials, including turning waste into hydrogen. Before I introduce the panel, I'll do that, and then we'll talk about some questions. I'll throw out some questions, and we'll have some discussion. But I'd like you to think about how you use energy. What do you do in your day? Where do you need it? And we'll hear some comments about that. And of course, you realize we only ever change energy from one form to another, right? You all remember your thermodynamics first law? There's no quiz. It's okay. So while you're thinking about that, let me introduce our panel. And I'll go in the order that we're here. So next to me is Milana Trikvich, my colleague in the same department, Chemical and Petroleum Engineering, here at the Schulich School of Engineering. And she is a Momentum Director for Energy. She has expertise and leadership in her field and serves as the Associate Editor for the Journal of Physics of Fluids. Milana is also an entrepreneur, having registered several patents and co-founded the startup Envicor, which is led by her former trainees from her research group. She's received a Killam Undergraduate Mentorship Award and a Diversity Award and Aztec Foundation Award for Excellence in Science and Technology Public Awareness. So welcome, Milana.
Thank you.
Next is Puneet Menon. He has a background in chemical engineer and leads the Energy Innovation Hub at Innovate Calgary. He's an alumnus of the Haskayne School of Business with over 20 years of experience in petrochemicals, processing, engineering, consulting, and research commercialization for designing innovation and technology programs. He's led the Southern Alberta chapter of the Western Canadian Innovation Offices Consortium and implemented the Calgary Energy Transition Centre in partnership with Avatar Innovations. Welcome, Puneet.
Thanks.
And at the end is Richard Masson. He's an energy expert and executive fellow at the School of Public Policy at the University of Calgary, with over 30 years of leadership experience in energy, project development and governance, energy marketing, and finance. Richard is known as a trusted advisor and effective communicator within the Calgary energy community and is a sought-after commentator on energy matters. I've seen you on the news. So
Many times lately.
He was the chair of the World Petroleum Council Canada, which hosted the 24th World Petroleum Congress in Calgary in 2023. Welcome, Richard.
Thank you.
So you can see we've all done a few things, right? Just like you, all of you who are here. So in terms of our discussion this morning, we want to think about balancing tradition in the energy sector with innovation. So how do we do that? So I thought we would start by breaking it down and defining some terms and then going from there. So overall, what we hope we leave you with today is how we can meet today's energy needs while paving the way to a sustainable future. So that's our goal. So let's set the stage. What is the trend in world energy demand, and how are these demands currently met? Is there anyone who would like to address that?
Well, I can go first, Josephine. So I think it's public knowledge. The energy demand in general is increasing, and it has increased at a faster rate in 2023 than it has in the previous years. And if you look at the distribution of that consumption, fossil fuels still represent about more than 70% of that mix. Now, within that increasing demand, there have been areas and there have been sectors and countries that have reduced their emission, but in general, it's increasing. And then also, I'll let others speak as well. So, but I'll just close off my comment by saying, in that increasing demand, I think the key thing that we have to focus on is triple E, energy, environment, and economy. And therein lies the challenge and some solutions as well. So I'll stop at that and let others comment as well.
Good. Richard?
My background has mostly been oil over the past number of years, including the oil sands, and that's kind of my lens. And when I look at energy demand globally, I still see oil demand increasing about 1 million barrels a day per year. So we're at about 102 million barrels a day, 103 million barrels a day of global demand. Alberta is, around 5 million barrels a day of production. Canada's exports to the U.S., which are very topical, hit 4.3 million barrels a day in July. So, we're a significant player. I get 4 or 5% of the global market, but the global market is increasing. And it's a complex system that we have, that we depend upon. And one of the things that is interesting is, if drilling slows down, the decline rate is 4 or 5% a year on a global basis. That's all the oil Alberta produces, lost in a single year. So it's a treadmill, and we have this ongoing need to continue to meet current demand until we're finding a way to replace it with something better, and that has been a challenge, and we'll probably get to that as we go.
Yeah, so I don't really have much to add to this already. If you look at as Richard and Puneet rightly said, so fossil fuels, obviously still the major game player. And if you look at the past, so in the past year, we have some positives also from penetration of, for example, photovoltaics, and in renewables are making a big jump into electricity mix. But that's also now, if you actually offset that with that increasing global demand, and it makes sense. And now if you start going to, where is that global demand coming from? And if you want to drive the economies of undeveloped nations, right, or developing nations, essentially it's going to be still tightly bound to, again, growing the energy sector, growing, and essentially goes usually hand in hand the emissions as well, right? So it is a complex, wicked problem. UN also stated it as one of their goals, clean energy, what that is. It's a really, a truly wicked problem, and it's a complex one. Thanks.
Yeah. So we've heard some comments already then about how energy, environment, and economy are linked. So let's define clean and efficient. How do we define those? Clean and efficient energy systems.
So so I look at it this way, clean tech in general could be defined in many different ways, but I think any tech that reduces the environmental footprint of an existing technology could be defined as clean tech. So from that definition, carbon capture, of course, would be clean tech. And then, or a technology that improves the environmental impacts or in general improving environment. So direct air capture would be a clean tech. So I think this is how I'll define.
Yeah, so maybe the way I see it, if you kind of think about clean tech, something clean tech does not have to be necessarily efficient, right?
Yeah.
So essentially, if you think about wind turbine and solar photovoltaics, the efficiency is maybe 30% on a good day, right? For photovoltaic still. But when it comes to why they clean, because the GHG emissions are minimal, right? But if you kind of think about something that is very efficient, so we can have a very efficient coal power plant, but it's still going not to be clean because it has still a very high footprint. So, one does not equate the other, right?
Yeah.
When I guess the other element that I'm seeing more and more is the wind and solar, because they're intermittent sources, are putting pressure on grids. And we're seeing that in Europe and Texas and Alberta. And so you're required to have dispatchable energy, usually from natural gas or something similar, to back it up. And it's a challenge because you're building parallel systems for use on the days when the wind isn't blowing and it's dark, and you need them because otherwise, the system starts to collapse. And so as we move through all of this, it's often said that clean tech's cost has come down a lot. I think that's true when it's been small parts of a bigger system, but as they become larger parts of the system, reliability really becomes a challenge, and we're starting to see costs of the overall system increasing. So it's as you said, a very big challenge.
Okay. So we've got a lot of challenges, as we just said here, right? There's cost, there's demand. So how do you see a sustainable future then? Maybe we can.
Yep, I'll
Same
go
order,
first.
I guess.
Yeah.
So I think I look at it from, in my head, I've simplified how to look at it. So I said triple E. So energy and economy, they have a direct relationship. So if economy has to grow, and this has to do with how we have set up our economic and social structure. Everything has to go onwards and upwards. So if you have to go onwards and upwards and have to be always on an increasing side of the economic output, then energy, of course, has to go. And if energy has to go, it has got its negative implications as well. On the environment side, unfortunately, the relationship with energy and economy is an inverse relationship. So I think that has to give. So I think that is wherein lies the challenge. So I think the solution doesn't lie in science and engineering. Science and engineering are already working at the very end of their thermodynamics and limitations imposed by chemical molecules and physics. I think it should be upon each one of us to make some choices. How do you ensure? Are we want to limit economic growth, or do we want to continue on this trajectory of increasing economic output all the time? But it's not a simple question, and it gets into so many different other aspects as well when you start to answer that question. But I'll stop at that and let the other panelists, jump in on this.
Go ahead.
I mean, part of that challenge, we had the World Petroleum Congress here last September, and I got to host some panels with people from the developing world, particularly Africa, and of course they don't have even clean cooking fuel, and so many die every year because of the fumes that come from their cooking in their homes. When you listen to that, you recognize that we've got a long ways to go. So it's I think many engineering solutions are required, but many economic solutions, many structural changes that allow us to bring the best technologies to the people who need it as quickly as possible. And the current system has been, coal dominates in developing economies. We need to be able to move away from that, even though that's the indigenous resource. things like LNG are going to be part of the answer to that. But in developed countries like Canada, where we put up barriers to developing projects like LNG, the direct impact is less available supply for these economies to base themselves on. So it's a bigger picture question. It's the UN, it's COP, it's all those things, putting in place the structures that allow for the development of the energy that we have that's best today, while still incenting innovation as we move forward.
Yeah, so I think it's really like, in a way, like a very much a dual approach to me, because I think like we have to keep on working, improving the efficiencies of the existing energy vectors we have. And I think oil and gas actually has done a really good job at that. If you think about like from 2000 until now, like the efficiencies have improved, the water usage has decreased. That immediately has transferred into less GHG emission per barrel, right? And I'm sure Richard could talk, probably has the numbers ready to actually point that. But and I think like that's the example where we can do and keep on doing on improvement of the existing energy systems. And at the same time, as Richard also pointed out, if you look at the clean energy vectors, right, like clean tech, so, okay, we want to have fuel cells. We want to have, if you think about it, we're far away from all of these like US Department of Energy targets, right? Green hydrogen should be $1 per kilogram. We're far from that still, right? Like, I mean, like if you think about like from the electrolyzers, from look at the photovoltaics, wind turbine, we still have like for these things to become feasible and truly widespread, then we still have to bring the cost down. And a lot of it boils down to still the innovation in the materials, in the way to essentially enhance the efficiencies, to enhance durability of these devices. But now, like, okay, let's assume the widespread adoption of this. Well, you still actually have a huge problem left, right? Because right now, if we're talking about even widespread adoption of the clean tech, we cannot forget about energy equity, right? Because we're talking about, okay, let's implement, but where can we implement these? They are more costly. So usually it will be still, if we always talk about like, off diesel initiative for our remote communities, but do these remote communities have resources to actually implement everything that we develop, right? So we have to, as innovators, really be mindful of that as well, that if we are developing these technologies, for them to be equitable, they have to be cost effective. And that's obviously still a gap left. Thanks.
So picking up some of those themes there, let me throw a question that's maybe a bit provocative. So should we stop what we're doing here and ensure that there is equitable access to resources across the globe?
Well,
I'll take a stab at it, Josephine. So let's step back, and I think I'll throw in a few more provocative thoughts as well in there. So first of all, the reason is why have we still been on fossil fuels, and why can't we get off fossil fuels? First of all, fossil fuels are the most dense concentrated source of energy, so it's very difficult to be off fossil fuels. They're mobile. They allow us for mobile applications, gasoline, diesel, and all. So, which no other source of energy except probably nuclear probably is able to provide. And then if we start to improve efficiency, although it brings down the negative emissions aspect of the fossil fuels, but it also results in a different incentives. It incentivizes us to use the more of the same. So although we're improving in efficiency, but on an absolute basis, we are still on an increasing trajectory on the GHG emissions. Now, the question is, and then this comes up in this conversation all the time, the question about absolute emissions globally versus per capita emissions nationally. And this is where the argument is. The people, the countries and jurisdictions and populations that are energy deficient, their argument is, we still need to have energy because our per capita consumption is still low. So, which is fair enough. We can't deny them the right of economic progression. So I think collectively we should be doing something to provide them access to energy and yet come up with systems that try to minimize the negative fallouts from those emissions if we were to continue on our trajectory to use fossil fuels. That would be my position, I think.
Other thoughts?
I mean, it's a challenge, right? There's just no easy answers. And so, I think oil is going to be a very dominant part of our energy mix for a very long time, for decades for sure. And so carbon capture, where possible on production, is a good thing. And Alberta is relatively set up to do that because oil sands projects are big, and big projects allow for economies of scale for capture technologies. So of the total CO2, about 20% comes from the production of the oil sands, for example, and 80% comes from the consumption. We can take that 20% down by half or more if once we commercialize these technologies, if Pathways is successful. That's helpful, but it's not going to be the answer. We've still got to deal with the 80%, and the 80% comes from alternatives that are going to have to be better, and that probably means an electricity system that's better than it is, reliability systems, batteries, storage that are better than it is, and so I think the opportunity for innovation here is just huge and is going to be with us for a very long time, both in the current system and in trying to find something new.
Yeah, I don't think we should stop doing anything about this. Obviously it would actually go against of everything as a professor, I believe. I think we have to keep on trying, but I think as I said, to me it's about very much a holistic approach. So going back to some of the comments, if you want renewable energy, you cannot really think about the renewable energy without a robust storage system. So it goes kind of hand to hand. And if you have that, what kind of electricity grid do you need, right? So all of these things are really highly interconnected. If you think about clean manufacturing, we should be also thinking about circular economy aspect, right? How do you actually, as Josie, you probably can talk more about it. So how do we actually convert this waste into valuables, right? And how can we make that more feasible? So, as I said, and for a lot of this, it's also a really group effort. And I think what I always leave from these discussions, it's essentially always kind of being a little bit inspired to do a little bit more in my own personal circle of influence, right? But also, as a community, we can do better, right? And I think we are always, it's always kind of for me, I seem to go into the cyclical kind of fashion when it comes to this. I get really optimistic and then I kind of drop down, nothing will actually happen ever. But there's always positive things, we move in the right direction and then something happens in the geopolitical strategy or whatever it is, right? That actually sets us back. But I think the hope is that we have these oscillations, but we are kind of going a little bit in the positive direction, right?
So, there's another comment I would like to make. So, when we talk about clean electricity and clean energy consumption in general, at least in the electricity space, I see two different and divergent approaches being discussed. And, it's interesting, which one is the best. I don't think we have an answer yet. So there's been a whole bunch of discussion going on distributed energy systems. And so that we save on the GHG emissions related to distribution and transportation of energy. And yet we also have discussion with regards to centralized grids, interconnected grids, just to leverage off opportunities that exist in different geographies and geologies. Again, our energy systems going forward are going to be increasingly complex. So what works in Canada may not work in the US and other parts of the world. So, and definitely we should be leveraging those opportunities, for example, geological storage systems in Canada, but then we don't have the world-class geothermal resources despite investing so heavily in geothermal. That's a different question though. So the question, I think this is where there is the exciting aspect for schools like us, Schulich School of Engineering and our upcoming engineering graduates, how do they enable, include policy, the science, and the societal aspects in helping decision makers make those decisions and include that engineering due diligence in that decision-making process as well, distributed versus centralized, and similarly for other sectors as well on the GHG emissions reduction and capture side.
So a lot of things to think about in the systems, and as I'm sure a lot of our audience members are aware, right, it's not just about that conversion process, but getting it places, the distribution, and so on. So let me ask you a quick question, quick answer. So should we move to nuclear?
Well, my view is we should absolutely. We need to diversify all the bases, and there are very few that have that kind of reliability. So we should move at pace, but I don't think it's coming easily or quickly to displace the volumes that we need. And part of the challenge is, even though we've been installing lots of wind and solar, we've been consuming all of that plus. And so that's why hydrocarbon continues to hold its market share. So yeah, we got to push nuclear hard, but it's going to not be a complete answer for sure.
At the risk of being slapped by someone, I would say yes, we should go nuclear. Just because, I think no matter which form of energy we use, there are going to be negative fallouts. So I think it's a balancing act. So I do not know how I'm going to justify the rest, but I think I would be supportive of considering nuclear at least. So I'll stop at that.
Yeah, I mean, I'll be more pragmatic about it, and I don't think we're in the position to actually throw anything out of the mix, because to me there's no clear winners when it comes to the new energy vectors, right? Nuclear obviously not new, but essentially being revived. And when I think about nuclear, and you obviously always think about the end of life of something, and obviously that's where the tricky part becomes, right? And the whole possibility of things going sideways in the process. But it's also kind of interesting to think about, when we talk about clean tech, we usually do not think about so much about the end of life. We think about okay, so this is a really good stuff going on, and reduce GHG emissions or none of it, right? But also you think about, for example, what chemicals do we use in a lot of these devices today, right? And how harmful they are. So I'm sure you heard about PFAS, so perfluorinated chemicals, right? And we use them. We throw them in the materials because they're really good. They're resistant, so they will actually last for a long time, but they will also last for a very long time in the environment. And they will also, accumulate in your body, and effectively, there's a proven studies that they cause cancer as well. So I don't think that, so there's a whole aspect of the research going on right now. How do we eliminate PFAS molecules? We use them in GPUs. We use them for data centers. We use them for the clean tech, and they're commonly found in the materials for electrolyzer, for fuel cells, and on coatings because, again, resistant, highly durable. So I think we're exposed to so much crap, going back to but we're, again, it's that public perception where I think, honestly, it's our role to essentially kind of also kind of put it into perspective. Yes, nuclear is dangerous, and nuclear, obviously, the end of life is something that we have to really think hard about it. But at the same time, it seems we're sliding these things through where they're potentially killing us slowly, and already for years and years and years, and we're not talking about, we don't have any good methods to recycle e-waste right now, and they're everywhere, right? So I think it's obviously a much broader topic. I don't want to take too much time about it, but this is just the option. So going back to the point, I don't think we should kick out nuclear from the equation.
Okay, so good thoughts there. So we have new technologies in artificial intelligence and data analytics, as you've touched on. So just briefly, as we're running out of time, but how do you view those as fitting in with the technologies? How can advancements in automation, AI, and data analytics help us? And what should our students be studying?
I can start this time to completely throw everyone off. So I think so I see, obviously, I think AI in energy vectors is AI in everything, right? There's always pros and cons, and there's dangers, and there's positive things about it. I think like AI, when it comes to like, the development, optimizing the grid, essentially like it's something that we can actually optimizing our processes. Can we actually look at it to also when it comes to the selection of the materials, or that we can actually look at if we want to, for example, phase out PFAS, what are the best replacement or the alternatives? So it really can have aspect on the multi-scale approach from every scale, in my opinion. When it comes to what the students should know, I think we should essentially have more knowledge about, and it's not only about our graduate students, undergrad students or our graduate students. So definitely we should be embedding more of the AI and then the usage of AI in the curriculum. And I think we're doing that to the certain extent. And at the same time also offer these continuing education courses for the people that are in an industry, because I did not personally take AI courses in my undergrad, but if the world is moving in the pace and that it's moving, then I think like it would be actually also useful to educate the people that are currently out there in industrial sector, also looking into implementing, how to implement this in the best possible way. So that's one aspect. And then at the same time, there's the whole aspect of how do you use it properly? Because I think, like, honestly, as a professor, I really fear that when it comes to, I think, like, we already have the effective use of the chat GPT, and how do you actually use it in the best possible way so that I mean, it enabled lots of things. Like, for somebody that, okay, English is my second language, I can understand and I can completely empathize with somebody that came like me and started undergrad in Canada and could not really speak English well at that time, right? And if I had ChatGPT then, oh, wow, like it would have been like, my life would have been so much easier. I remember my lab reports taking me forever, because it just essentially put the sentences, it was really tough, right? Like, so I think like there's aspects that are useful in the chat GPT. But there's also like this problem of learning, right? Like, I mean, where I worry that there's this fake sense of, I can just get the answer easily. There is that beauty of going to the library and digging through the books and finding the answer and really critically thinking. And what I worry about, and it's essentially something for us as educators to think about, how do we actually enable both still?
So I think what I'm going to do, I know you guys probably, Richard and Pune, probably have thoughts too, but I'm hoping that we have some questions from the audience. So I just asked each panel member to give a final thought, and I think one of the comments Richard made about 20% of the emissions are from the production, 80% from use. What are the, if you can think of one thing that you think we should educate the public so they understand better, what would it be? So quick, just one sentence. Richard?
One of the things I would point out is that Alberta sits on unique geology, and we have the ability to sequester vast amounts of CO2. And one of the things that the government of Alberta did right was put in place a regulatory regime and a liability regime for that a long time ago. And so we've had Shell Quest injecting 1.4 million tons a year, and Northwest is now doing 1 million tons a year. And we've got this, and it's working, and it's demonstrated. And so that puts us in one of the relatively unique positions of the world. So even when we think about AI, there are now data centers coming to Alberta because we can put gas-fired power, which is reliable, with carbon capture. And we're going to see that we're at the front of that whole wave because of our geology. And I think it's the people, the experience we have from oil and gas and the development of that, and the geology that we sit on that's going to put Alberta in a leadership role in many of these things that eventually can benefit the rest of the world.
Thank you.
So Josephine, I'll circle back on that triple E equation that I mentioned earlier on. So I think we are up against an existential challenge with regards to the emissions not coming down at faster rate than expected. So rather than looking at engineers and our political masters and other leaders to come with solutions, I think I would like to reflect back on myself as an individual and encourage the same for you to think about what exactly are willing to contribute to help mitigate that triple E conundrum that we are in nowadays. Yeah.
Yeah, so I mean, maybe going back to, I believe I said earlier, I think it's important for each one of us to actually first educate ourselves so as much as possible, understands the pros and cons, and really, like, going from the resources to the end of life of everything that we actually are in the energy mix, and really do our best to do whatever we can in our circle of influence, but also educate the public, right? I would love to see more engineers going to the politics, to be quite honest. So I'm not going to be one, but hopefully, I'm always telling this to my class, go to politics.
Yeah.
I think you would actually have like a good decision-making skills over there too. So thanks.
Thank you. So please join me in thanking the panel. Are there questions or thoughts? Yeah, I think we have a microphone that can come around. This one question out there.
I would have done that myself, been in politics.
First of all, I'd just like to thank the panel. It's the most rational discussion I've heard about energy for quite a while. Your message was pretty clear that the sources of energy will become increasingly diverse. But there's one that you didn't mention at all, which, if we succeed, could be a one-stop shop, and that's fission energy. Is anything happening there?
Anyone want to answer that?
I mean, for me, what I always go to when I want to learn more is the ARC podcast, so the ARC Energy Research Institute. They've done podcasts on fission and the challenges that it faces, and it's again, it's a long ways off from everything I've learned. I'm a finance guy though, so I'm not going to get too deep in this. Somebody probably knows more than me.
So I've heard some positive news come out from EU with regards to fusion experiments, but again, we are ways off in having that a reality and used commercially, but things are happening. But again, it's again a separate conversation, more than couple hours long at least. Yeah.
So it's a good question, and part of it we just went through accreditation and the idea of lifelong learning, so we can all learn more on that. Other questions?
Okay, suppose that we're down the track, and like a lot of the goal seems to be to remove carbon emissions from the system. Let's say that involves getting rid of all of those thermal fuels, and it's not just the energy industry that they impact, but I guess, do you see a future for things like coal and oil and gas outside of generating energy and whatnot down the future? Is there a path for it forward beyond just being in the energy industry?
Yeah. One of the things that I think people don't recognize is of oil, I think something like 20% of the total use is for plastics. Plastics are going to be awfully hard to replace as well. And there are things like in Alberta, the initiative around bitumen beyond combustion, trying to use bitumen in other ways. Certainly, even if we end up with electric cars everywhere, we're going to need essentially heavy oil and bitumen to pave roads, which is a relatively less carbon intensive use of it. So there's things like that, but it's part of the need for it right now is so large. I think the number is 82% is the last number I saw of our total energy uses from hydrocarbon. It's just, that's part of the answer, but it's going to take a lot to really move it to zero.
Yeah, I'll just add to this. The simple answer is yes, but I think it also depends upon the yes, and how strong that yes is depends upon how we monetize and value what we value as a society. So we have valued fossil fuels for the energy content. So if we were to value that less and value something else, definitely yes. Carbon fibers, materials can definitely be derived from petroleum products. And yeah, definitely yes. But then again, if we were to also find replacement fuels or energy sources for what we use fossil fuels currently, that definitely yes.
Yeah, so I mean, Richard already pointed at the use of plastics, right? Like, we use plastics in the everyday life, but also, wherever we end up using, the point is, I guess, like, the same way that we're using them in hydrocarbons, when we use them in the plastics, that end of life becomes a problem, as again, right? Like, so I think, like, however we use them, the problem is like that essentially holistic approach and thinking about it from the whole life cycle assessment, right? I mean, we recycle less than 10% of our plastics today, and it is a huge problem, right? And especially like the amount of microplastics that we're generating from plastics as well, and it's not really easy to replace plastics as well, as pointed earlier. But even if you think about like microplastics generation, like we still don't find, according to Canada's health, like we don't actually find them as like so bad yet, but in, for example, European Union, they are classified as like really bad for you. So they will do a lot more to essentially how do they prevent them. So the sustainable plastics is a huge aspect that we also have to think about. So it doesn't matter how we use and where we use the fossil fuels. I think like the problem kind of persists, right? Like we have to think about like also how do we not like, make the life for the next generation worse than we have it today, right?
So lots of challenges, but lots of smart people, including our audience. So I think we're up for that, and we've had a great conversation. Thank you so much for our panel, Puneet, Richard, and Milana. We had a great discussion. So I'll turn it back to Anders to finish our breakfast.
Thank you so much, Josephine. And thank you to the whole panel, so Josephine, Milana, Puneet, and Richard, for this insightful panel discussion this morning. And also many thanks to all of you in the audience for spending part of your morning with us. I know it was a little chilly this morning, so thank you for braving the winter weather to come in here. Do stay safe, walk and drive carefully when you leave here this morning. I hope you'll enjoy the rest of your day, and with this being the final Schulich Connects of 2024, I'll also take the opportunity to wish you a wonderful holiday season, spend some time with friends and family, and a happy new year. Thank you so much.
Thanks for tuning in to this Schulich Connects, proudly sponsored by TD Insurance. We'll see you next time.